Well, hello guys. Welcome to 8.3 on two-step conversion factors. Today we have a really awesome guest. He's our chemistry enthusiast. This is Mr. Millsap. Mr. Millsap, say hi. He's very, very excited to be here. Cannot contain his enthusiasm. So, Mr. Millsap, we'll just dig right in. You ready? Okay. So, in a two-step conversion factor problem, it's going to be very similar to the ones we learned at 8.2, except that we're going to be adding on one more conversion factor to the problem. So as you see listed here on the left, we have the same steps that we had for the one-step conversion problems. The only difference is that this problem is going to be a little bit longer. So we're going to follow these steps. So if I'm looking at, this is my problem right here. This is my sample problem. When I'm looking at this problem, and we'll read it aloud, there's actually a typo. It says, in a reaction, one of the products you form is a compound called iron 3 sulfate. That should not say sulfate, it should say hydroxide. Whoopsies. And then we keep reading. It says, how many molecules of iron 3 hydroxide would you produce from the reaction if you produced 34.2 grams of iron 3 hydroxide? Okay, so Mr. Millsap, if we're looking at this problem, what's the very first thing that we should do?
Find the given.
Right. And so our given, remember, is the only number in the problem. Okay, so what's our given in this problem?
34.2 grams of iron 3 hydroxide.
Right, so I'm going to highlight the whole thing. That is my given. What's my final unit? Because that's the second thing we have to identify. What am I trying to go towards? What am I trying to convert to?
Molecules.
Molecules of what?
Iron 3 hydroxide.
Right. So I start with grams of iron 3 hydroxide, and I'm going to molecules. So this is my given, label it G. This is my final one, I'm going to label it F. So we've done step one. Yay! Doesn't that feel great? Okay. So number two is we're going to set up our T-chart. And here's our T-chart right here. What do we always put at the top of our T-chart?
The given.
Right, and so I'll put 34.2 grams of iron 3 hydroxide. If I write 34.2 grams here, I'm kind of missing a step. We talked in 8.1 about how we need to write out the identifier next to the unit. So we know I have 34.2 grams, but I don't know what grams I have. So do I have 34.2 grams of baking powder? Do I have 34.2 grams of what? So I would need to write the formula for iron 3 hydroxide here, so I would identify what these grams are relating to. So from last semester, Mr. Millsap, do you remember what the Roman numeral 3 stands for? Okay, well, a lot of students are probably in the same position as you. They don't remember what the Roman numeral stands for. It is referring to iron. Remember, iron is a transition metal, which means that it does not have one charge. Its charge transitions depending on what it's bonding with. So that 3 is kind of a little hint. It's like a psst, iron. This particular iron has a +3 charge. Psst. So that's what that 3 stands for. So since iron has a +3 charge, and then hydroxide is the second part of that formula, hydroxide is a polyatomic. So in order to find the charge of hydroxide, we would need to look on our polyatomic chart. I happen to have the charge memorized. It's -1. So OH, which is hydroxide's formula, has a charge of -1. So we know, and this is all last semester stuff, that we would need 3 hydroxides. So our formula is FeOH3. That's our formula for iron 3 hydroxide. Okay, and then what do we always put on the bottom of our very first fraction?
1.
1. Always, always. Given is always going to be over 1. Okay, so now that we've done that and we've set up our T-chart, what's our next step?
Finding the conversion factors.
Okay, and then what two conversion factors are we always given?
Moles to particles and grams to moles.
Right. So we have moles to particles, which is right here. And remember, particle stands for atoms, and it also stands for molecules. And then we can also convert from grams to moles. So we have to find these conversion factors. Which ones are we going to use? Well, remember how I say I always write out my thought pattern to figure out like where I'm going. Okay, so I'm starting with grams, right? And then what do I want to end up in?
Molecules.
Okay, so grams I can find in this conversion factor, but this conversion factor does not convert between grams and molecules. It converts between grams and moles. the second conversion factor on the right has molecules in it, but it doesn't convert from grams to molecules. It converts from moles to molecules. So I don't have one conversion factor that gets me from grams to molecules. Does that make sense? So if I'm starting here, if my given is here, what do I have to convert to before I can convert to molecules?
Moles.
Moles. So I'm going to go grams to moles, and I'm going to use this as my first conversion factor because it will get me from grams to moles. Once I'm in moles, I can use the second conversion factor to get me to molecules, which is my final unit. So this is my second conversion factor. So I'll go grams to moles with the first one, and then moles to molecules in my second one. Okay. So basically what that means is I'm not going to have one conversion factor here. I'm going to have dose, which means 2 for those of y'all who aren't bilingual. Okay, so we're starting off with grams right here, grams of iron 3 hydroxide, and we're going to end up in molecules. How do I know what's going to go into this very first fraction here?
The unit on the top of the first one is always at the bottom of the second one.
Right. So if I have grams right here at the top, I have to have grams of iron 3 hydroxide on the bottom. Why is that important?
So that the units cancel out.
Right. I want grams canceled out. So we are kind of already talked about this, but which conversion factor do I use that's going to have grams in it?
Moles to grams.
Right, this first one right here. It has grams and then moles. So this part here we're going to put on the bottom. We're going to put my molar mass down here. And then moles, 1 mole of iron 3 hydroxide goes on the top. So 1 mole iron 3 hydroxide goes on the top. And that's really because I've already used the grams on the bottom, down here. And so what's the other part that's left over in the equation? That's the 1 mole. So I put that on the top. Normally what we would do now is we would stop and we would calculate what this molar mass is for iron 3 hydroxide. For right now, I want us to finish setting up the whole thing, and then we'll go back and we'll fill in what number goes next to the grams, okay? Okay, so now we're on to we've done the first conversion factor. Now we're on to the second one, which is going to go right here, okay? So I have 1 mole, and then I also have 6.02 times 10 to the 23rd molecules. Which one goes on top and which one is going to go on bottom?
Molecules goes on the top and moles goes on the bottom.
Okay, why are we going to put 1 mole on the bottom?
Because it's on the top on the previous one.
Right, we want to cancel out of moles. Since mole is on the top here, I need to cancel it out by having mole on the bottom on the next one. So since we've used moles, what does that leave to go on the top right here?
6.02 times 10 to the 23rd.
Molecules, right. So we put 6.02, Avogadro's number, 10 to the 23rd, molecules of FeOH3 goes here. And then remember, the way we know that we're totally finished with our T-chart is if the unit at the very top, at the very end, if this is our final unit, then we know that we're done. And we know that our final unit up here was molecules of iron 3 hydroxide, and we see that that's also the last unit at the top of the fraction. So we've essentially set it up correctly. Now we have to go back and we have to figure out what number is going to go right here. Well, I'm going to kind of show you an alternate way to calculate molar mass. If you're comfortable with the first way that I taught you in 8.1, then go for it, do it, that's fine. This is a faster way to do molar mass of long compounds. So we have FeOH3. So what I've ended up doing, we know that you have to find the molar mass of each of these, and then you have to add them together. Since we have 1 iron, and iron's molar mass is 55.85, I just write it like this, and I'm going to add it to the molar mass of oxygen. Well, we don't have 1 oxygen, do we? We have 3 oxygens. This 3 right here stands for 3 H's and 3 O's. So I'm going to put a 3 here, 3 standing for 3 oxygens, and each oxygen's molar mass is 15.99. And then I'm going to write hydrogen. So this was irons, this was 3 oxygens, and this is going to be 3 H's, okay? Because remember, this 3 is standing for how many H's we have. So I have 3 H's, so 3 times the molar mass of hydrogen. So if I just add all those together and multiply them together, I end up with 67.03, and that's grams per mole. So this is the molar mass number of iron 3 hydroxide. So that's the number I'm going to plug in right here, 67.03. Now, if I want to solve this problem, Mr. Millsap, we've kind of already done steps 1 through 4, and now we're on step 5. So what do I do next?
Multiply all of the top.
Yes, and if I multiply 34.2 times Avogadro's number, I end up with 2.06 times 10 to the 25th, and then my unit is molecules. And then if I and then the next step is to multiply everything on the bottom, which is really easy, right? 1 times 67.03 times 1 is still 67.03. And then what's my last step?
Divide the top by the bottom.
Right, and so when I divide these two numbers, I end up with 3.07 times 10 to the 23rd molecules of iron 3 hydroxide. Okay, we're going to do one last problem, and then the last example problem you can work on your own, and I'll show you guys how to complete it in class. Okay, so we're starting here. We have convert 4.12 times 10 to the 24 atoms of tin into grams of tin. So, Mr. Millsap, where do we start?
First, we identify the given.
Okay, and what's our given in the problem?
4.12 times 10 to the whatever that I can't see it.
24.
10 to the 24th atoms.
Right, atoms of tin. That's our given. And then what else do we do?
Identify the final.
And my final is grams. Okay. Now that I've done that, I have to set up my t-chart, right? And how do I set up my first fraction of my t-chart?
You put the given over 1.
Right, and so I write 4.12 times 10 to the 24, and the symbol for 10 is SN. Oh, whoops, I should have wrote atoms. Atoms of 10. And what goes on the bottom?
1.
1. Always 1. Good. So next, we have to find our conversion factors, right? Okay, so we're in atoms. This is what we have, right? That's our given. And we want to go to grams. That's the final. So we're going to have to use two conversion factors because they're not in the same conversion factor. So if we're in atoms, what do we need to convert to first?
Moles.
Moles. So this will be our first conversion factor. Once we're in moles, then we're going to use the second one to convert into grams. Okay. So that means Avogadro's number of atoms equals 1 mole is our first conversion factor. So I have to use that in my first fraction. Where do I put 6.02 times 10 to the 23rd atoms? Do I put it on the top or the bottom?
On the bottom.
Why do I put that on the bottom?
So that the units will cancel out.
Right. My atoms of 10 can cancel out with this atoms of 10. And what goes on the top?
1 mole.
Good. And if we forget, if we don't know what goes on the top, all we have to do is we have to look up this first conversion factor. I've done this part of the equation, so what's left is the 1 mole. Okay, so now that I'm in moles of SN, I have to go from moles of SN to grams. So 1 mole, and then my molar mass of 10 in grams are going to make up my next fraction. Do I put 1 mole on the top or 1 mole on the bottom?
On the bottom.
Why do I put 1 mole on the bottom?
So that it cancels out.
Right, so mole of SN cancels, mole of SN cancels. What goes on the top of this fraction?
The molar mass of 10.
Right, so grams of 10 goes on the top. Now, how do I find the molar mass of 10?
Looking at your handy-dandy
periodic table. That's right. So when I look at the periodic table, it says my molar mass is 118.71 grams of tin and 1 mole of tin. So now that I've set that up, I have 3 math problems to do. I multiply the top, I multiply the bottom, and then I'm going to divide that fraction. 812.29 grams of tin. And a way to check yourself before you wreck yourself is to check this last unit on your T-chart. If your last unit is the final unit, grams, then you're good to go. Sound great?
Sounds awesome.
And that is it for Mr. and Mrs. Millsap's 8.3 video on two-step conversions. Go ahead and try and work through this last question on your own, and then we'll go over it in class. Thank you very much, and thank you, our special chemistry enthusiast guest, Mr. Millsap, for being here today. You all have a wonderful day. Bye!